Alright, I want to give you some examples of what we went over in class the other day. And so we're going to start off with some problems that deal with the one-to-one property. So when we look at this one right here, you recognize that on the left we have 216 as our base, and it's raised to an exponent of 2x. And on the right we have 36 as the base, and it's to the power of 4 minus x. So right now I can't use the one-to-one property and say that the two exponents are equal. But if I can set these so that the bases are equal, then I can set the exponents equal. So it's pretty easy to recognize that 36 is the power of, or 6 raised to the power of 2. So it's like putting this in parentheses and saying, well, that's the same thing as this. But don't forget it's raised to the 4 minus x. And when I've got a power raised to a power, I multiply the two. So this is going to give me 6 to the, distribute that 2, 8 minus 2x. On the left side, you may not recognize that 216 is 6 raised to a power, but because we're dealing with these types of problems, usually they give you something where you can break this down into the same base. If not, we'll discuss those on another video. But I'm just going to take and punch in my calculator and say, or you can just divide it out on the side, say, is 216 divisible by 6? And doing the long division here, you see that it is. 6 times 36 is 216. So 216 is the same thing as 6 cubed. And so this is like saying 6 to the third raised to the 2x. And once again, I'll multiply those powers, and I'll get 6 to the 6x equals 6 to the 8 minus 2x. Now that I've got the bases equal, I can set the exponents equal. And then I'll get x equal to 1. Okay. Now, try the next one on your own. This is number 2 here. See if you can get these to the same base. Alright, so you should have paused the video and noticed that, hey, 9 is the same thing as 3 squared. So this is like saying 3 squared raised to the 2x minus 1. 27 is the same thing as 3 cubed. And so this is 3 cubed raised to the x plus 4. Multiply those powers there, and you get 3 to the 4x minus 2 is equal to 3 to the 3x plus 12. Since the bases are the same, I can set the exponents equal. And I'm going to get 4x minus 12 is equal to 3x plus 12. Not minus 12, minus 2. And then add 2 to both sides, subtract 3x, you get x equals 14. For number 3, this is going to be 5 squared raised to the 3x plus 6. And this is 5 cubed raised to the 12 minus 2x. Distribute that 3, and you get 36 minus 6x. Distribute the 2. Now that the bases are the same, set the exponents equal. Not 48. I'm doing my math wrong here. This is going to be 24, so x is going to equal 2. On each of these, you should be pausing it to see if you can work it out before you see me do it. And so this one's a little bit different just because we don't have a whole number now, but it's okay to have a negative exponent. It's okay to have a negative fraction right there. The main reason when we're talking about extraneous solutions, some students get mixed up, is when we're talking about logarithms, we can't have take the log of a negative number or the log of 0. So it's okay to have a negative value in our exponent. Recall that if we have x to the negative 3, that's the same thing as 1 over x cubed. Or if we have 1 over x to the negative 5, that's the same thing as x to the 5th. So it just switches the number from the numerator to the denominator, or the denominator to the numerator if it's negative. It works is too fast. I'm messing up my drawing here. So number 9 gets into logarithms. So I'm going to save that for the next video. And that gets you through 8 of them, and that's using the one-to-one property with exponents. So hopefully that helps, and keep working hard.